Next topic, ammonia. That means we have to discuss about its preparation and properties. Here two preparation methods are there. One is the laboratory method and one more is Haber's process. This assignment process is not there in our syllabus. This is urea formula. When urea reacts with water, then ammonium carbonate is formed. When it undergoes heating, then we get ammonia. This is laboratory method. Haber's process, that means by using Haber's process we can make ammonia. When nitrogen gas is passed through hydrogen gas in the presence of iron metal or mixture of FeO or Al2O3 or K2O, then also we get ammonia with the pressure of 200 atmosphere and the temperature 725 to 775 Kelvin. This is already we discussed in class 11 chemical equilibrium chapter. So this is also one of the method to prepare ammonia. Next, properties. In solid and liquid state, ammonia forms hydrogen bond. It is highly soluble in water due to intermolecular hydrogen bond with water. So NH3, here nitrogen is bonded with hydrogen so that it can form hydrogen bond. So what is the point here? In solid state and liquid state it can form hydrogen bond. Why it is not formed in gas state? Because in gas state molecules are in free motion, so that automatically the attractions between molecules decreases. Finally they cannot form hydrogen bond with other molecule. Next, one more point is what? It is highly soluble in water due to intermolecular hydrogen bond with water. This is the melting point of ammonia. This is the boiling point of ammonia. Next, drying of ammonia. Ammonia can be dried by using quicklime. Quicklime formula CaO. It cannot be dried by using strong dehydrating agents like H2SO4 and P2O5, etc. Because these are strong dehydrating agents. By using them we cannot dry ammonia because these are strong acids. Ammonia weak base. So when we use these compounds reacts with ammonia. That is why these compounds cannot be used for drying of ammonia. Only it can be used. Which one? Quicklime. Its formula is CaO. Next, chemical properties of ammonia with acids. When ammonia reacts with HCl, then it can form ammonium chloride. Similarly, when ammonia reacts with H2SO4, then it forms ammonium sulfate. Next, complex formation. When copper ions reacts with ammonia, then it forms complex compound. These are complex compounds. When any compound contains square brackets, those compounds are called complex compounds. That means ammonia can form complex compounds. That is the point here. Next, with the Nessler's reagent, the formula for that is K2HgI4. Potassium mercuric iodide is called Nessler's reagent. Simply it is called Nessler's reagent. When potassium iodide reacts with mercury chloride, then we get potassium chloride and HgI2. Again that HgI2 reacts with 2 moles of potassium chloride. Finally we get Nessler's reagent. So this is the manufacturing of Nessler's reagent. Here one important point is there regarding this one. To prepare 1 mole Nessler's reagent, to prepare 1 mole of K2HgI4, we need 4 moles of K. 2 plus 2, 4 moles of K is needed. Then suppose to make 1 mole K, how many moles of K2HgI4 is needed? Such type of questions we face in competitive level. To make 1 mole K2HgI4, 4 moles of Ka is needed. To make 1 mole Ka, how many moles of K2HgI4 is needed? So what is the answer? 1 by 4 K2HgI4 moles needed. So we may face such type of questions in competitive level. Next, uses of ammonia. Ammonia is used as laboratory reagent. That means by using ammonia we can make some other compounds. Next, it is used in the manufacture of fertilizers like urea, ammonium nitrate, etc. Next, it is used as refrigerant. Refrigerant means To keep the substances cool, to make the substances cool, we use ammonia. To make the substances cool, for that we use ammonia. That is why it is used as refrigerant. Next, preparation nitric acid. Its formula HNO3. It is also called aqua fortis. One more name for HNO3 is called aqua fortis. Here two methods are there, like ammonia. One is laboratory method and one more is Ostwald's process. In laboratory method, HNO3 can be made by reaction of potassium nitrate with H2SO4. Then HNO3 and potassium bisulfate are formed. This is laboratory method. This is industrial method. This method is not there in our syllabus. Ostwald process. In that process, 3 steps are involved. In the first step, starting reagents are ammonia and air. That means when air is passed through ammonia in the presence of platinum or rhodium catalyst at a 500 Kelvin temperature and 9 bar pressure, then we get nitric oxide along with water. When this nitric oxide reacts with oxygen, then we get nitrogen dioxide. Again this nitrogen dioxide reacts with water, then finally we get HNO3. So these are the steps involved in Ostwald process. From this process we get 63% HNO3. That means rest of the part is water. This on distillation, then we get 68% HNO3. Again this is treated with a dehydrating agent like H2SO4, then we get 98% HNO3. And finally it is treated with a freezing mixture, then we get 100% HNO3. So like that we can make nitric acid by using Ostwald process. Next, chemical properties. These are very important. From this topic we usually face these questions in CBSE level from this topic, especially nitric acid. First reaction with zinc. When zinc reacts with dilute HNO3, then we get zinc nitrate and N2O and H2O. Again when zinc reacts with concentrated HNO3, here this is dilute HNO3. Dilute means some amount of water is there. Here concentrated HNO3. Then also we get a zinc nitrate, but here in this case nitrous oxide, but here nitrogen dioxide. Here one important point is there. If you take concentrated compound, then we get more amount of oxygen in the product. I repeat once again, if you take concentration compound, then we get more amount of oxygen. See here zinc nitrate is there, here also zinc nitrate is there, here water is there, here also water is there. What is the difference? Here N2O, here NO. That means compared to here number of oxygens are more. Next, with copper. When copper reacts with dilute HNO3, then we get copper nitrate, nitric oxide and H2O. Similarly, copper reacts with concentrated HNO3, then also we get copper nitrate and nitrogen dioxide and water. Next, with the non-metals. Suppose when carbon reacts with HNO3, then we get CO2, NO2 plus H2O. When sulfur reacts with HNO3, then also we get H2SO4, NO2 and H2O. So these are the chemical properties of HNO3. These are very important properties. You have to practice them very well. Next one. Here one important question is there for 1 mark, that is aquaresia. The mixture of 1 part of HNO3 and 3 parts of HCl is called aquaresia. The mixture of 1 part of HNO3 and 3 parts of HCl is called aquaresia. The reaction regarding this one is HNO3 plus 3 HCl gives rise to NOCl plus 2Cl plus 2H2O. Here the point is what? These chlorine atoms are called nascent chlorine. That means very powerful chlorine atoms. When noble metals like gold, platinum are dissolved in Aquarius due to nascent chlorine atoms. This is very important point. These chlorine atoms are called nascent chlorine atoms. Aquarius is what? One part of HNO3 and three parts of HCl. Gold and platinum, these are very stable metals. That means unreactive, less reactive. That is why the cost of gold and platinum is very high nowadays. But though when those metals present in this mixture, those metals also lose their nature because of nascent chlorine atoms. Next one, brown ring test for nitrates. That means this is the topic regarding laboratory. When any compound reacts with ferrous sulfate and hydrogen sulfate, then we get this compound that is called brown ring complex. Why? Because this compound is in brown color. Next here, the oxygen state of iron in brown ring complex is +1. This is very important point. What is the oxygen state of iron in brown ring complex +1? Because H2O neutral, so oxygen state 0, NO +1, here -2, +1 -2 -1, and that -1 goes to that side, then get +1. So finally oxygen state of iron is +1. Next, uses. It is used as laboratory reagent. That means by using this reagent we can make some other compounds. Next, it is used to prepare nitration mixture. Nitration mixture is 1:1 ratio of HNO3 and H2SO4. That means one part of HNO3 and one part of H2SO4 is called nitration mixture. Next, it is used as oxidant in rocket fuels. So these are the uses of HNO3. So this is all about HNO3. The rest of the topics are not there in our syllabus in this year. So this is all about 15th group elements. In this chapter we have to learn only equations. We have to practice them. There nothing is there to explain. Thank you.